All right, let's take a look at example 7 in the notes. So this is the one on medical coverage. So according to the report in the Sacramento Bee, 11% of Californians lacked medical insurance after the passage of the ACA, down from a previous rate of 17%. Suppose a random sample of 80 Californians was taken after the passage of the act. Find each of these probabilities. So first of all, let's make sure we understand why this is a binomial distribution. And remember that there are 4 things we said had to occur. The first was that we have to have a fixed number of trials. So in this case, the number of trials are the number of people sampled. So that means that n equals 80. So that condition is taken care of. The second case was that each trial had to have 2 outcomes, one success or probability of success versus probability of failure, 2 outcomes. In this case, the success that we're interested in, because we're interested in looking at the probability that more than 15 lack insurance. So the success, so to speak, is that they lack the insurance. So in each case, or in each trial rather, there are 2 outcomes. They either lack insurance or they do not lack insurance. The probability of success on each outcome has to be the same. So what is the probability that somebody randomly selected will lack insurance? That's the 11% that we're going to go with that they gave us as a statistic. So P is going to be 11%. So I'm going to put 0.11. And the trials have to be independent. And of course they are, because they said it was a random sample. So the 4 conditions there are met for us to apply or to see that it's a binomial distribution. So for part A, we're looking for the probability that more than 15 lack medical insurance. So the probability that X is greater than 15. And if we write out our binomial distribution, that notation we talked about in class, X is binomially distributed with 80 trials, 11% probability of success, and we're interested in the first part that X is greater than 15. Okay, so this notation's a little different. I'm not just putting 15 there. I'm going to put X is greater than 15. But the idea is we're going to put all of this into StatCrunch and figure out what the probability is. If you flip the page, if you have StatCrunch pulled up, I'd go ahead and put these numbers in just for practice. But if you flip the page, you can see the probability for the first one. So there's the distribution. You can see that it looks like it's roughly symmetric because we have a large sample size of 80. The probability was 11%. And so rather, the probability for each success is 11%. But if we put this into StatCrunch, and I hope you do this, I can't show you on the computer right now, but if you get your laptop out and you go into StatCrunch and you follow the procedure we talked about today in class, and we want to look at this time the probability that X is greater than 15, it should give you a distribution that looks like this. And when I do this in StatCrunch, I am getting a probability of about 0.0128, it looks like, if we round it to 4 decimal places. So, oops, let me move that so you can see it, 0.0128. So if you try that, make sure you get the same number I do. Now for part B, it's the same information, but they asked us for a different probability. They said, what is the probability that between 10 and 20 inclusive lack medical insurance? So notationally, we're looking for the probability that X is between 10 and 20. So that's what we're going to put into StatCrunch. So again, if you go into StatCrunch, so do this with me on your laptop, go into StatCrunch, put in the information, N is still 80, the probability of one success is still 11%. Now you have to click on the between option, and then you're going to put in your lower bound of 10 and your upper bound of 20 and click compute. And when you do that, you should get a probability that's approximately equal to 0.3844, rounded to 4 decimal places. Okay, so for the next section, we talked a little bit today about these formulas. So if you're asked to find an expected value or a mean for a binomial distribution, you're just going to multiply the number of trials by the probability of success for each outcome. And for standard deviation, it's going to be the square root of n times p times q. Remember where q is the probability of failure. So this example in the coin toss is very short. It says, suppose you toss a fair coin 15 times, binomial distribution, because you're either going to, you have 2 outcomes for each one, heads or tails, and of course the other conditions are met. It says count the number of heads. Find and interpret the mean of the probability distribution. So in other words, what is the expected number of heads we should get in 15 flips of the coin? So if we use that formula, mean is going to be equal to n times p. So n is the 15 trials, and then p is, so the probability of landing on heads, of course, is 50%. And so basically 50% or half of 15 gives us 7.5. So what does this mean? It says interpret it. What does this mean? We are talking about what we would expect. This is the expected value. If we toss the coin 15 times, we expect about 7 to 8 flips will land on heads. And that should make sense if you think about it. Half of what we toss, we expect to be heads, right? If I flip the coin 20 times, we expect 10 of them to be heads. 15 times, 7.5 is technically half of that. So somewhere between 7 and 8 of those flips should roughly, about that many should land on heads. Okay, the second example we did with the Buster Posey example, I'm going to go through it again because I know we did it kind of quick at the end of class today. So the expected value we said was, again, the mean, which is n times p. So if he bats 480 times in a season, that's the n value. And his probability of getting a hit was that 30.8% or 0.308. And so if we put that into our calculator, I think in class I gave you a number with a decimal. It was 147.84. You could say 148, I think, or even 147. That would be okay. And then for the standard deviation, we said we're going to do the square root of n times p times q. So for this example, that's going to be the square root of 480 times the 0.308 times the complement of that, which was about 0.692. And so if you put that into your calculator, you should get about 10.11. So give or take about 10 hits is what we expect. So that's the standard deviation. Now, what do we expect? So remember, back in chapter 3, we said that if we have a symmetric distribution, what's usual or expected is within 2 standard deviations. So the expected value, or what we expect him to get in a season, should be within 2 standard deviations of the mean. So what we did is we said, okay, take the mean, add or subtract 2 of those standard deviations. So 147, I'm going to leave the decimals, 0.84 plus or minus 2 times the standard deviation. And if you work those numbers out, you should get a lower bound of 127.6 and an upper bound of 168.1. So we expect him to get in a season somewhere between about 127, maybe 128, and 168 hits. So would it be unusual if he gets 120? Well, remember our cutoff is 2 standard deviations. So if he gets 120, he's below 2 standard deviations because this was 2 standard deviations below the mean. So yes, this would be unusual since 120 is, let's see, you could say outside of 2 standard deviations, or you could say more than 2. I'm going to just put sigma for standard deviations below the mean. Now, another way to check to see if this is unusual is to calculate the z-score. Remember, z-score represents the number of standard deviations something is away from the mean. So if I calculate the z-score for this 120, and if it's greater than 2 or less than -2, we know it's unusual. That's another way you can test that. So on the next page, that's what they show at the top. So it says, we know 120 is beyond 2 standard deviations below the mean. To determine if this would be surprising, then we can compute the z-score. So remember the formula for z-score. It was x minus mu divided by sigma. Now, just to be clear, we've already answered the question. So what we did a second ago, if you show me that that number is outside of 2 standard deviations, that's good enough. But you could also calculate the z-score and figure this out that way. This is another way of doing it. So if we do 120 minus the mean of 147.8 divided by our standard deviation of 10.11, if you put that into your calculator, I'm getting a z-score of roughly -2.75. So what does that tell you? 120 standard or 120 hits is 2.75 standard deviations below the mean. So it's almost 3 standard deviations below the mean. Would that be surprising? Absolutely. So yes, this would be surprising since this is almost 3, I'm going to just put sigma for just to be quick about it, 3 standard deviations below the mean. And so you could either calculate the z-score or actually figure out what 2 standard deviations below the mean is numerically and then show that your number that you're interested in is outside of that range. Okay, let's take a look at example 10. It says the midterm exam in a mathematics course consists of 45 multiple choice questions. Each question has 5 possible answers and only 1 is correct. An unprepared student makes random guesses for all of the questions. So this is a binomial situation because on each question, either you get the answer right or you don't get the answer right. So there are 2 outcomes on each question. Assuming they're independent, that every question, the probability of one question correct does not necessarily affect the other, assuming the questions don't have anything to do with each other. And we have a fixed number of trials. So the number of trials, n, would be the number of questions on the test. So n is going to be 45. What is p? The probability of success on one trial. Are they equal? Yes, because each question has 5 possible choices. So the probability of getting it correct would be 1 out of 5. Q would be the probability of failure. So that's going to be the complement of p. So 1 minus 1/5, which gives us 4/5. Calculate the mean, the number of correct answers for each student. So how many answers, if the student truly guesses on all 45 questions, how many answers should he expect to get correct? So we're going to calculate the mean by doing the n times p again, because it's a binomial situation. So we can do 45 times 1/5. Well, so 45 times 1/5 is going to give us, let's see, that should give us 9. So 5 goes into 45 9 times. And so he would expect to get about 9 answers correct on the test. So for part E, it says calculate the standard deviation. So we're going to do sigma equals the square root of n times p times q. So remember that that would be the square root of 45 times 1/5 times 4/5. And of course, you can make these decimals if you like. This is 20% times 80%. So let me put this into the calculator. So 20% times 80% times 45. And then if we take the square root of that, we get about, I'm getting about 2.68 if we round it to 2 decimal places. Okay, and then the question says to determine the range of usual values for the number of correct answers on this test. Again, we're going to go 2 standard deviations above and 2 standard deviations below the mean. So let's go ahead and do that. Just checking my answer there. Yeah. Okay. So 2 standard deviations below, we're going to do 9 plus or minus 2 times the 2.68. So the lower bound, so if we take 9 minus, I'm putting these on the calculator here, 9 minus 2 times 2.68, I'm getting a lower bound of about 3.64. Actually, let me write it this way, 3.64. So I'll say my lower bound is 3.64, and then my upper bound, 2 times 2.68 plus 9, I'm getting an upper bound of 14.36. Now, obviously, you can't get a 1/6 or 6/10 of a question, right? So you could say somewhere between, you could say 3 to 14 questions, you could say 4 to 14 questions, whichever way you round it is fine. But this is about what we would expect. If he's really guessing, he would get somewhere between these 2 values, or these 2 number of questions correct. And so it says, to earn 60% on the exam, a student would have to guess 27 questions correctly. Would this be unusual for a student to pass the exam by simply guessing and getting at least 27 questions correct? Well, so think about it. If 2 standard deviations above the mean puts us at only 14 questions correct, is 27 going to be considered unusual? Yes, absolutely. That's going to be really unusual. We could calculate the z-score. It's going to be a very high z-score, but you can just say that yes, since 27 is well above 2 standard deviations over the mean. Sorry, I didn't leave you a lot of room here. Well above 2 standard deviations below the mean. So that definitely is going to be unusual for a student to pass the exam by simply guessing. Okay, so let's take a look at example 11. It says Florida had a high school graduation rate of 82.3% in 2017. Suppose we take a random sample of 15 students. So how do we define success in this exercise? So I'm thinking we probably want to know what the percentage of students is, or what the probability of a certain number of students graduating. So I think graduating would be the success here, and that's the statistic they gave us, the 82.3%. So graduating is going to be the success event. What is the probability of success? So that is the 82.3%. I'm going to write it as a decimal, 0.823. And then it says, what is the sample size? So sample size is what we selected. We selected 15 students, so n equals 15. And then in a random sample of 15 students, what is the probability that exactly 9 will graduate? So get your stat crunch out, because you're going to need to put this into stat crunch to get your answer. So we're looking for, what are we saying? We're distributing this binomially. N is 15. P is the 0.823 number. And we're wanting to know the probability that exactly 9 will graduate. So I'm going to go into stat crunch, and I'm going to put this information in. I'm going to change my sample size n to 15. The p-value is the 0.823. Make sure that you select standard and not between this time, and then select the probability that p equals 9. P is exactly equal to 9. And I'm getting about 0.027 if I round it correctly. So double check yours against mine and make sure you get the same answer in StatCrunch. And then part E, it says same thing, a probability, random sample of 15 students. What is the probability that 8 or fewer will graduate? So go back into StatCrunch, and what you want to do is change, instead of just having equals 9, you want to change it to the probability that x is less than or equal to 8. And I'm computing that to be about 0.009 if we round it to 3 decimal places. And then the next question, it says, what is the probability that at least 9 will graduate? So when you put that into StatCrunch, select the probability that x is greater than or equal to 9. And I'm getting a probability for that of 0.991. Are any of these events complementary? So probability that we get 8 or fewer or 9 or higher, those events are complementary. And you notice, by the way, if you add these two probabilities, what do they add up to? 0.009, 0.991, they add up to 100%. So mathematically, you can see they're complementary that way. But either you are 8 or fewer. This is kind of like that mistakes question we had about making mistakes on a quiz. Remember that question from chapter 5? Kind of the same logic. The probability that we have 8 or fewer or 9 or higher, those will be complementary. So events E and events F are complementary. Okay, let's take a look at the chapter 6 quick review questions. So number 1, it says, which of the following is a discrete variable? Remember, discrete are things we can count. So the only thing in this list that we can actually count is C, the number of passengers in a car. The rest are actually measurements, so those would all be continuous. Okay, question number 2, it says we have a normal distribution, and this information, make sure you know what this means. 64 is the mean, 3 is the standard deviation. So this gives good approximation of U.S. adult women's heights in inches. The question says, what percentage of U.S. women would we expect to be taller than 61 inches? Can we compute this by hand? And so first thing we're going to do is draw a picture. Please, every time you do a normal distribution question, make sure you make a sketch of what you're talking about, even if you have to use StatCrunch to get the actual calculations. So 64 is going to go right in the middle. And then since the standard deviation is 3, if we go up 1 standard deviation, that puts me at 67. If we go down 1 standard deviation, that puts me at 61. So the question said, what percentage of U.S. women can we expect to be taller than 61? So 61 is here. So taller than that means that we would shade to the right. So can we figure this out without using StatCrunch? Can this be computed by hand? Well, remember what the empirical rules said. The empirical rules said that if we think about what's within one standard deviation of the mean, remember, so from 61 to 67, that is about 68% of the data. So if you break this down, make sure you can see how I'm drawing this. 61 to 64 would be 34% of the data, so half of 68, in other words. And then 64 to 67 would be 34% of the data. Now, I could go through and break all of the standard deviations out and fill in each section, but think about it this way. 64 is the mean. So what percentage of the data would be above 64%? And that would be 50%, right? Because that's half the data. We want to go above 61%. So between 61 and, I'm sorry, not 61%, 61 inches. So between 61 and 64 inches, that's 34% of the data. So if I want the probability that X is above 61 inches, I'm going to add the 34% from this section right in here, plus the 50% for the rest of the data. And so that gets us a probability of 84%. That might be a good test question because you don't need StatCrunch to figure it out. You can use the empirical rule. Now the next question, same data, but they want us to go from 62 to 65 inches. Okay, so if we're going from 62 to 65 inches, 64 is still in the middle. 62, however, is somewhere between the mean and one standard deviation below. Remember, one standard deviation below was 61 inches. I'm only going to go to 62 and then up to 65. Since those are not numbers that are at individual standard deviations, so like in other words, they're not 62 is somewhere between one standard deviation below and the mean. 65 is somewhere between the mean and one standard deviation above. To figure this out, we would have to use StatCrunch. So can this be computed by hand? No, it cannot. So if you go into StatCrunch, practice this, go into StatCrunch, make sure you know what buttons to push. But our probability here, it's close to the 84%. It ends up being about 84.1%. And then lastly, it says what height corresponds to the 90th percentile. So let's make a quick sketch. This time they're giving us the percentage, and they want us to figure out what's the measurement, what's the height. So we know 64, of course, goes in the middle. Think about 90th percentile. That means 90% of the data is below this particular number. So that means the number 90% below, that means the number has to be somewhere over here. I don't know what it is, so I'm going to put K. I think that's what we used the other day in the notes was K, just to signify that variable. But we want 90% of the data to be below that. And since 90% doesn't follow our empirical rule, 90% below, so 90% of the data is what I've got shaded in here. We're going to have to go into StatCrunch to figure this out. So we're looking for the probability that X is greater than or equal to K. So this is one of those ones where you put in the percentage, the probability of 90%. You set the probability X is greater than or equal to, and you leave that blank for K. And when you compute it, you end up getting a K value of about 67.84, which should seem about right. 67.84 inches would be up here somewhere pretty high above where the mean of 64 is. Number 3, it says the standard normal model. Standard normal distribution. You have to know what those words mean. Standard normal is the standardized normal distribution where the mean is at 0 and the standard deviation is at 1. So make sure you remember that. Standard normal corresponds to a special distribution where the mean is 0 and the standard deviation is 1. Which of the following is not a characteristic of the binomial probability model? Remember, you have to know these 4 characteristics. This will be on the test, so make sure you know all 4 of these. Only 2 outcomes are possible for each trial. Yes, we have to have that. That's why it's called binomial. The probability of a success has to be the same for each trial. Yes, so from one trial to the next, the probability is the same. There has to be a fixed number of trials. Yes, they have to be, that's your n value, right? Whatever the fixed number of trials are. The trials are dependent. No, so that's the one that's not the case. Actually, in fact, the trials would have to be independent. If it had said independent, that would be the fourth characteristic, but it said dependent, so that's the one that's incorrect here. Last question. So this is similar to what we were doing a few minutes ago. We were talking about the mean and the standard deviation for a binomial distribution. It says a random sample, well, let's back up. Unemployment rate in a state is 8.2%. If we take a random sample of 500 residents, what is the probability that more than 50 are unemployed? So what we're looking for, so N in this case is 500. So let's see, so N is 500. And the probability of success, so in this case, success is unemployment, so that's 0.082. We want to know the probability that more than 50 are unemployed. So N is 500, and I misspoke a second ago. I said we're using the mean. We're actually not using the mean yet on this part of the question. This is just a regular calculate the probability. So N is 500, probability of success is 0.082. So we're looking for the probability that X is greater than, more than 50. So if we go into our into StatCrunch and we put this information in, the probability that we get more than 50 residents who are unemployed is about I'm getting 0.064, I believe. Let me just double check that. 0.064. Check it and just make sure you get the same thing. We want greater than, not greater than or equal to. Make sure you pick the right thing for that. 50, and I'm getting, let's see, put in the right N value, 0.064. Yeah, I'm getting the same thing. So that should be the answer you get when you put that into StatCrunch. Okay, so the last question here is more like what we would put on the test, right? Because you don't have access to StatCrunch. So this last question says, let me see if we can make this a little easier for you to read. Move the camera around just a little bit. Okay, a little bit better. Hopefully you got this in front of you on your paper. So it says, would it be surprising to find that 50 are unemployed? So we're looking for the mean and the standard deviation, and we want to go out 2 standard deviations to see if 50 is unusual. So we need to get the mean first. The mean or the expected value is, remember, N times P. So 500 times the 0.082. And that gives us, I'm getting a value of 41. 41 people is what we'd expect in our sample. The standard deviation, so that's going to be the square root of N times P times Q. So if we fill in our numbers for that, that's the square root of 500 times 0.082, and then Q is the complement, so 0.918. And I didn't leave you much room here, but I'm getting a standard deviation here. I'll write it over here, of about 6.13. So 6.13 is the standard deviation for the mean of 41. So would this be unusual? Well, let's see. So if the mean is 41, 2 standard deviations below the mean, what would that be? So 2 standard deviations below the mean. So if we do 41, let me get my calculator out here. If we do 41, let me write it down here. 41, subtract 2 of those standard deviations. I'm sorry. Yeah, 41 was the mean. What do we get for a lower bound? So 41, take away 2 times 6.13, and I'm getting a lower bound of 28.74. If we do the upper bound, 41 plus 2 times the standard deviation, let's see what that gives us. So 2 times the standard deviation plus the 41. I'm getting an upper bound of 53.26. So take a minute, think about that. Would 50 then, in that case, would 50 be considered unusual? And the answer is no, right? Because 50 is within 2 standard deviations. So no, this would not be considered unusual since the mean is 41 and the standard deviation was 6.13. 50 is only about, it's going to be, if we calculate the z-score, I think we end up getting about 1.5 for the z-score. So it's about 1.5 standard deviations above the mean. So this is not more than 2 standard deviations. Okay, what percentage of the data should fall within 2 standard deviations? Remember your empirical rule, 95% of the data should fall within 2 standard deviations.